Okay, hello everybody and welcome. Thank you for joining us this lunchtime. I'm David Wood from the Pacific Science Center, and I'm going to be your host for today's virtual Meet a Scientist. Before we meet today's scientists, I'd like to remind everyone that educational programming like this is made possible in part thanks to the generous support of donors. In the face of challenges like COVID-19 and climate change, science and an informed public are absolutely essential. So to help us ensure that curiosity never closes, or for more information about donating to the Pacific Science Center, visit PacSci.org/support. The scientists that we're going to be meeting today are members of PacSci's Science Communication Fellowship Program, which offers training and support for local STEM professionals and connects their work to public audiences. So under more typical circumstances, our Science Communication Fellows deliver hands-on activities at Meet a Scientist, which happens twice a month on Saturdays at PacSci. But obviously now our doors are currently closed to the public, but we still wanted to provide you with the opportunity to meet some of the fantastic local scientists who have committed themselves to science communication. Today, our Science Communication Fellows are going to be discussing their experiences as professionals, but also as individuals. We've got a few questions planned, but this conversation might go in all sorts of weird and wonderful directions. If you have a question, a comment, a story, you just want to let us know how you're feeling today. I know folks have already been chatting on the comment section. You know, perhaps you are thinking about becoming a scientist. Perhaps you're the parent of someone who's thinking about becoming a scientist. Maybe you're curious about the work that these scientists do, or maybe you yourself are a scientist and you want to share your experiences and something that we've spoken about today resonates with you. So again, please leave all of those questions, comments, stories in the YouTube comments section, and we will try and get through as many of those as we can. We do this so that you can connect with the scientists and our scientists can connect with you. So without further ado, I'd like to welcome our first scientist to the live stream, Dr. Beth Mundy. Hi, Beth, how's it going?
Hi, it's good.
So Beth is a recent graduate in the Department of Chemistry at the University of Washington. I'd also like to welcome Dr. Brenda Kessenich.
Hello.
Hey, Brenda. Brenda is also a recent graduate in the Department of Chemistry at the University of Washington. You both defended your PhDs recently. I'd also like to welcome Dr. Delwin Elder. Hello there, Delwin.
Hello, everyone.
Welcome. Delwin is a research scientist in the Department of Chemistry at the University of Washington. And our final scientist that we're going to meet today is Zack Cohen. Hello there, Zack.
Hello.
Zack's a graduate student in the Department of Chemistry and the Astrobiology program at the University of Washington. If you couldn't tell, we've kind of got a chemistry vibe going on today. Okay, so let's start things off. I've got my questions here. First question, Zack, I'll start with you. Tell us what it is that you do in STEM, maybe with about 60 seconds time there.
My research is about trying to figure out how the first cells formed on Earth. So billions of years ago, what kind of chemistry was going on to give you the first cells?
Awesome. Dr. Elder, just briefly let everyone know what it is that you do in STEM.
Okay, I am working in a field that's largely, or that's under the umbrella of organic electronics. So I work with organic chemicals, which are carbon-based materials, but there's an electronic component. And in order to have that application, they have to be able to interact with electric fields and optical fields. And so they are engineered so that they can interact with light and electric fields. And one of the main applications is for electrical to optical signal transduction on optical fiber networks. All of our computers and cell phones and electronics run on electrical signals on electrons, but all of the data is transmitted in a fiber optic network. And so at some point you have to convert those electrical signals to optical signals and do it at a very rapid rate. And so the materials that we work on are organic chemicals, but they interface with silicon chips and are able to do that electrical to optical signal transduction, and have to do that at a very high rate. And we're trying to even push the envelope even further.
Thank you for that. Dr. Kessenich, are you getting used to the honorific yet?
Sort of. It's barely, it hasn't even been a month. It'll be a month since I defended in a few days.
Well,
so yeah, it's fun though.
It's super weird for me too, Brenda. So
I've been making everyone call me doctor though, because like,
I mean, yeah,
I worked for this.
Well, Dr. Kessenich, tell us a little bit about what you do in STEM.
All right, so my graduate project was all looking at how water and soil interact. There's a thing called soil water repellency that happens sometimes where soil doesn't readily absorb and retain water, which is bad if you're trying to grow crops. But we don't really understand at a molecular level how that happens. So I spent the last 5 years working with a model system to try and figure out how I can control the water repellency of just a very simple system, depending on what molecules I mix into it. Now I'm writing a bunch of postdoc applications. I'm focusing a lot of that on understanding how biofilms form. Those are antibiotic resistant little networks of bacteria that can form on medical equipment or on other mechanical parts like ship propellers. And that's another place where we don't have a great mechanistic understanding of how all these little pieces come together and form a greater whole.
Thank you. Finally, Dr. Mundy, tell us a little bit about your work in STEM.
Yeah, so the work that I did in graduate school was all focused on finding new and more efficient ways to make materials for various energy types of applications at the nanoscale, so at really, really small size scales. And we're particularly interested in using materials that are relatively environmentally benign. A lot of the best materials out there for all these different applications are very toxic. So that was a really big focus for us. And currently I'm working as a freelance technical copy editor. And so with that, basically what I do is I get technical documents and manuscripts, typically written by non-native English speakers, and help ensure language clarity for things that get published, all the way from, someone writing comments on someone else's paper through very, very long manuscripts.
Well, thank you for setting the stage there. I have a confession to make. You were all in the Department of Chemistry. Chemistry was my least favorite subject by a long way. Okay, but so my first question is why am I wrong? What's exciting about chemistry, and what gets you excited about the work that you do, and what's some of the what are some of the great applications of chemistry? Zack, let's start with you.
So I actually at one point kind of agreed with you. I think in high school I really liked chemistry because we made liquid nitrogen ice cream, and we did all sorts of cool demos. Then in college, I thought organic chemistry class was really hard, but now I'm back in love with chemistry, and I think that's just because it's, there's so, at least for me, it's fundamental to the things I am curious about in the world. It's such an important part of our world. I think there's so many interesting questions in chemistry. Yeah, so that's why I like chemistry. Yeah.
Anyone else?
I'd like to jump in. I definitely loved chemistry when I was a kid. I just was always trying to figure out how things work. What is, why does a tree leaf have its green color? Why does why do different foods taste differently? I mean, all of those go down the questions of chemistry. And as a kid, I think a lot of kids are curious in that way. But then once you actually start learning about it in a rigorous way in school, somehow it becomes a little bit less fun. But I think, I certainly found the more that I went on in chemistry, my first couple of years were, I definitely liked it. I mean, I liked it, but I think the more that I went on in school, I liked it even more. It's almost as if you have to get past a certain point till you can really know enough to really appreciate it even more.
Yeah, I agree with Delwin. I think I didn't really love chemistry kind of earlier on because, there's a lot of, it's a lot of memorization. It's very a lot of early chemistry to me is kind of like rote problem solving, like plug and chug sort of thing. And that's not, I don't find that exciting. But I think what really kind of switched for me was when I started doing research, because then it's this kind of constant, asking all of these different questions, and you're figuring things out on a very kind of, in my mind, it feels like a very kind of precise, fundamental level, but also you're not so far disassociated from real world applicability. Some of the materials my graduate group worked on are things that are going to be put into devices, into like display screens. So it feels still fundamental science, but also not so fundamental that you can't see how it can impact the world.
I actually got started as a geology major when I was an undergraduate, but then switched to chemistry after I realized that in all of my geology classes, all of my questions came down to, but what's this made out of? And I just got really stuck on but what's it made out of? How does this material work? Why is this thing sticking to this other thing? And that's kind of stuck with me into the point where now basically every research proposal I write is, how does thing A stick to thing B?
Well, thank you all for those answers. I'm going to shift gears slightly. So part of the reason that we do Meet a Scientist is because it provides a platform for you guys as scientists and for our local community to connect with each other. Given that you're live on PacSci's YouTube channel right now, is there anything that you feel compelled to share with our community in this moment? I'm not going to call on anyone. Is there anyone who feels like they would like to just share something now while you've got the time?
Sure. I think it's always a good time to acknowledge that our society is fundamentally, structurally unequal in a lot of ways. I think that's coming to light in a broader audience right now. So I do want to take this opportunity to point out that a lot of STEM is still really lacking on racial and gender representation. We're fortunate enough to be in a chemistry department that's, I believe, 40-60 female to male. So that's really cool. But as with many other chemistry departments that I visited when I was looking for grad schools, it is still largely an East Asian and white department. It doesn't really represent the diversity of the American public. So that's just something that it's important to remember. I think as scientists, we like to sometimes not think about that, but that's something we should all be remembering right now.
I also want to say that's something I think, people are starting to really think deeply about and grapple with. People who have had the privilege to be able to ignore it are thinking about it more broadly now. But I think it's also something that the chemistry community in particular is having to really deal with. And I want to say that specifically, I've seen a lot of chemists start to really do some work, and there's always the hope that things will change, but I think a lot of people are starting to try, which is good.
Yeah, I would like to say, just looking back on my career, and it's been 20 years since I got my PhD, and I worked in industry for 10 years, and now I've been at the University of Washington for 10 years. And it's the way that chemistry works is that people have ideas, even in industry where have specific products that your company makes and sells, as well as in academia where things are a little bit more open. But in order to get work done, people have ideas and they talk to other people to build on ideas, or to try to convince them to work on ideas, or try to convince them to fund ideas. And so there's a lot of, just individual conversations that are going on. And, sometimes people get left out of those conversations. And, people that are of racial and gender minorities can get left out of those conversations. And it's not something that necessarily, that other people are conscious of or consciously leaving them out of. But, it does happen more often than not. And, I think it's good looking back on what's been going on in our country in the past couple of weeks, to all of us to think about that and think about how we can be more inclusive.
Yeah, I just would say that I agree. I think it is good that we're starting to shed light and have these discussions about diversity in STEM, and yeah, it's encouraging.
Yeah, it's a relief because I've done a lot of equity work in grad school, and in some ways I feel like I've just been like banging my fist on a door for 5 years, being like, why won't anyone listen to me when I'm trying to tell you about things? And now it's finally like people are starting to think about it, which is really nice.
Yeah. What kind of mechanisms for support, have you found, Brenda? If it can be frustrating, like you've mentioned, beating your fist on the table. What has helped you? What has helped you with that?
Oh boy, that's a big question. I think so. I guess I'll start with just like some personal stories of why I came to the University of Washington. A large part of it is that when I came here for a visit weekend, like in 2015, there was a Women in Chemical Sciences group that gave a little speech at the lunch for the visiting students, and that was something that said to me that, okay, people here care about equity, and that'll be a place that I can go to if I'm feeling left out of other places. The other part is that being trans, I wanted to live somewhere where it was going to be easier to transition versus not. So those factors kind of combined to bring me here. So a lot of it is just cultural climate for a department, and having an organization with like Women in Chemical Sciences, which is now called Inclusion in Chemical Sciences, around actually makes a really big difference for that, because it just shows that people are working on something and they care about it.
I also want to say that not only do those organizations exist, and there are some in some different departments and different kind of like institutes affiliated, but those organizations. So I was also, during my time in grad school, very involved with Women in Chemical Sciences. I was the president and gave one of those speeches. But not only do those types of organizations exist, but they have departmental support. So there was buy-in not just from the students, but there was clear buy-in from some faculty and some of the like larger structures. And that's something that I didn't really see when I was looking at grad school, but that I realized was important as I was there.
Thank you for sharing those experiences. Oh, Delwin, sorry, go ahead.
Yeah, I was just going to say that grad school is hard. Something that people don't often think about, but it can be very hard and long, and you can oftentimes feel like you're out there, struggling alone. But I think a lot of people have that same experience. And one thing that was really helpful to me in graduate school, I didn't go to graduate school at University of Washington. I went to California Institute of Technology. But there was a diversity department, and the diversity director was very proactive at going out and checking with students, and just to check on them, see how they're doing, and also organizing events to bring people together. And I found that to be very helpful. And just in general, having a good way to cope with things and to relieve steam and have things outside of the lab, outside of school to fall back on and entertain you. I found those friends in graduate school to be very helpful in helping me to get through, and they're still some of my best friends now.
Yeah, thank you to all of the friends out there that support everyone, and thank you to the people that do diversity and inclusion work, because it's a long haul. But thank you for sharing those experiences. Zack, do you have anything you'd like to add? So I'll move on to Delwin. You mentioned grad school is hard. What are some of the obstacles and challenges that you folks have faced during your careers? It's not smooth sailing, is it? Would anyone like to speak to that?
I would just say, when you're in high school, in college, I mean, your grades are letter grades. You learn material from a textbook, and you're tested on it, and it's a very much more direct path between what you learn and what you're supposed to learn and your grades, how you're scored. And in graduate school, you're not really graded that same way. In my school, I had, classes for, a year and a half. After that, it was all just lab work, and the way that you're scored is very different. You don't, your GPA almost, is hardly relevant. It's how successful you are in research, how many papers you publish, how you impress your advisor for a recommendation at the end of the time, as well as just what you learn and how you can translate that in a job interview and then later into job performance. So understanding that and learning that in graduate school and learning how to do research was very different. And, you almost had to learn what you needed to learn before you could learn it in graduate school.
I would say, so for me, I almost left graduate school. I almost left in my third year. One of the things they don't tell you is being successful in grad school is a combination of, skill and determination and also luck. And I got really unlucky. For the first basically 3 years of grad school, I was on a couple long-term projects that didn't go anywhere. They were just completely unsuccessful, or they were unsuccessful in that they didn't lead to publishable results. And it can get really draining when you're working really long hours, you're really putting your heart and soul into this, and you feel like you're not making any progress. So for me, that was, I think, the biggest challenge was just, it was just failing for years. And I'm very fortunate that I had an extremely supportive advisor who, when I went to her with this, was like, okay, we figured out a new project that after about 6 months of initially failing did then lead to the bulk of my thesis work. But that's something that I don't think you realize is, I was always really good at school. I was really good at classes, but that isn't really a good indicator of how well you're going to do in grad school. And that's where also having those support kind of systems was really helpful. But that was really, really hard for me, just not being able to feel like I was moving forward after literally years.
Yeah, I think that's still something I'm coping with is, kind of the highs and lows of doing research. I feel like when my experiments are working out and I'm collecting cool results, just, life feels great. And then when experiments start not working for whatever reason, often not your fault, that has been really hard to take, especially because, like Beth said, you invest so much time and effort and thought. You care about this a lot. So it's kind of hard when things aren't working well. So for me, I think the helpful thing has been kind of taking a step back, taking a break, having other things going on, outside of just doing research. That is, I think, realizing that is just, sort of inevitable, and knowing how to cope with that has been really important.
I would echo having a good work-life balance in grad school feels sometimes like it's impossible, but I think that's the only reason I've been able to finish my PhD. Because after I moved here from Colorado, and I had grown up in Colorado, had lived in the same 60-mile radius for my entire life up until graduate school, and moving out here and being stripped away from all of everything I had known up until that point, just my mental health was in the toilet my first year of grad school. And I entertained dropping out a lot during that first year because it was just so terrible to start over in a new place. But I think actually, weirdly, once I started doing research and was done with classes, things got a lot better because I was like, finally, no one's giving me a grade on this. I can just go muck around in lab for 8 hours, and if something works, great. And if it doesn't, that's fine.
Yeah,
I was gonna say, I missed grades in research because is this good? Yeah. I don't know. Will someone just tell me that I'm doing a good job? Like, can you just give me like a stamp that says like, you know, I take a B-. I just need to know where I'm at.
Yeah, I definitely do feel that at a certain point. It was just like, why won't anyone tell me how I'm doing? Yeah, and I think another layer of complication on this whole grad school thing has been just like being queer and like trying to figure out and navigate that space and undergoing gender affirming medical procedures while also being in grad school has been like a whole thing. Because like I missed 6 weeks of work last year for a surgery, and that's like 6 weeks of work in like the last year of my PhD. So that was 6 weeks when I wasn't writing a paper and wasn't working on my thesis, and that was a lot of time. So it's like all these things add up, and it can be difficult.
Thank you all for sharing those experiences. Science doesn't always go the way you expect. We've touched on that. What are some of the ways that you have failed? It could be a funny story, it could be a scary story, it could be something that made you mad. What's a way that you failed in science, and what did you take from that experience? I'll leave that open for whoever wants to start.
I have a story about a broken pipette.
Let's hear it.
So there's a facility on campus that houses all these like really fancy microscopes, atomic force microscopes, that are the main instruments that I use. And they had a pipette in there for measuring out liquid and solutions. And I had been using that to just like measure out, okay, I'm going to put 100 microliters of something in here, and tomorrow I'll come back and do 200 microliters. And then I discovered, this droplet that's 200 microliters kind of looks like it's the same size as the 100 microliter droplet. Oh no. And I had to throw out several months of work because I had just been doing the same concentration over and over and over again.
Yeah. Ooh.
Yeah, it was rough.
So I have one. So it was my first year of grad school. I was, you know, little baby grad student. And I was undergoing what at the time was kind of like this like big kind of initiation. Like, don't want to make it weird, but to the lab where it was this one particular synthesis that was very, very, very dangerous. And so we always, you know, you had to go through separate trainings with it. And everyone had to work with a buddy system. So I had been paired up with a senior grad student so he could kind of show me the ropes. And it was to make this particular phosphorus precursor, but you had to start by making NaC, which is a sodium potassium amalgam, which it turns out if you mix solid sodium with solid potassium in the right ratio, it turns into a eutectic mixture and becomes liquid. So you have this like a ball of liquid metal that is extremely dangerous. It is highly explosive. So, you know, we do this. So we're really careful with this. Like we're being super, super careful because we're aware of how dangerous it is. We bring it out of the glove box because we've been doing everything air free. We like get things set up, and then we have to let it react overnight. And we come back the next morning, and there had been what we term a catastrophic glassware failure, where somehow we still don't entirely know what happened, but something failed and the flask exploded. Inside the hood, there was soot all in this like really special air-free glassware system. So a Schlenkline, for those of you who know it, which has all these little tiny tubes of glass. Yikes. Also trying to clean soot out of that with a pipe cleaner, not fun. But we still had this oil bath, which had, for it to our benefit, had acted as a secondary trap to keep air and water from these explosive materials. And so we had to quench that, so dispose of it safely. And at the time, my boss was about 8.5 months pregnant. And we went into her office, we're like, we don't know what happened. We're so sorry. And so she was like, you know, massively pregnant, directing us on how to properly like dispose of these materials. And this was my first time trying it. I was terrified. And it's, you know, again, very fortunate that there were like, you know, a senior grad student helping. We were able to do everything safely, but it was just like my first time trying this like big thing. Was a disaster. But that's the only time I had anything like explode in the lab. So
Yeah, I can think of one thing that was, it wasn't funny then, and it's still not funny now. But I'll talk about it anyway. But I was working with butyl lithium in the lab and was about to syringe some out. And for everyone who's listening, butyl lithium is a pyrophoric liquid, which means that it can spontaneously ignite into flames when it comes into contact with air. I was syringing some of it out on the bench top, and my syringe came separated from my needle. And since I had the bottle under pressure, pumping in nitrogen pressure, then there was a fountain of liquid that was coming out of the bottle that was catching fire. So I had this little flammable, this flames shooting out of this bottle, and
God.
I kind of
that sounds awful.
and was running around yelling "fire, fire!" But it was kind of in the evening, and there was only one person around, and he was way at the end of our lab, and so he didn't even hear me. So I was running around trying to figure out what to do, and got a bucket of sand which we had around and dumped it on there to put it out. But my heart was pounding at 100 beats a second, it felt like, and it was a very tense situation. Fortunately, nothing was in the way that caught on fire, just kind of spurted out on the floor. But accidents do happen, and failures is a big part of doing science. But you kind of learn from it.
Yeah, I guess fortunately don't often work with very dangerous chemicals.
Yeah, same.
Every time
I was
really
gonna
I have
say
to
you
go
could tell the
PV,
synthetic
I
chemists from
Yeah.
But I think maybe my story about failure is I at one point was working on sort of these mixtures of chemicals, and I thought I had discovered this like really exciting reaction, and I was looking at it on a mass spectrometer. So I had this one mass spec signal, and I was doing all these experiments. It was consistent with this what I was hoping really it would be, and I couldn't think of any other sort of alternatives. So I was really excited about that for a while. And then eventually, someone thought of the alternative, began to test that, and of course, that's what was actually going on. So it was just kind of like a disappointing, again, like a high and low of just the process of doing science.
Well, you live and you learn. I think chemists can fail more spectacularly than others might be able to. And speaking of which, I know that for me, like the science teachers have like this kind of great chaotic energy about them. You do all sorts of fantastic experiments. We do great shows at the Science Center. It happens in schools. But who or what inspired you to pursue a career in STEM? Did you have any memorable STEM teachers?
So for me, I grew up in a very small rural town. STEM, that wasn't really a thing for most people. Like my hometown has like maybe 4,000 people. But my aunt and uncle are both STEM professionals. And I remember in particular, my aunt, when I was, a little kid, took me into the lab where she was working and like popped me at 6 years old in front of a microscope. And I thought it was like the coolest thing ever. And I think she's one of the people who like showed me that, again, as for me, I didn't know scientists in my hometown. When you see scientists in the media, especially 20 something years ago, predominantly men. So that I had a clear example of a successful woman in STEM who encouraged me. And that was really powerful.
And I remember in high school, my chemistry teacher was doing all these cool demos, and I actually got something else. I wouldn't really say that's what inspired me to go into STEM. I mean, you would do things like just dip like a racquetball in liquid nitrogen and then just whip it across the room at the wall and just have it shatter. And I'm not really sure what kind of chemistry it was trying to like. Just liquid nitrogen is cold, I guess, but it was awesome. I mean, that was the kind of thing like it was super cool. But I think for me, like watching movies has been really inspiring about really like sci-fi basically. So I mean, one of the things I'm very interested in is just the idea of life in the universe, like, and making that a research question. So like I watched the movie Contact in high school, and that I thought that was awesome. Yeah, I think sci-fi is a big source of inspiration.
Yeah.
Actually, that's kind of similar to where I got it, because like I don't know that there's like a specific person that got me started. I do like my first memories of someone asking me what I wanted to be when I grew up was like I was super into dinosaurs when I was 5, and then I was super into space when I was like 7 to 10. But actually, I got really into Star Trek when I was a teenager, and I'm going to blame that for why I'm a scientist, because it was just like like the whole concept of just like, let's go explore things and find out what's going on out here and learn about it. I was just like, yes, this is what I want to do.
Yeah, I would definitely echo the TV and movies as inspiration, because that certainly inspired me too. I mean, much more, I definitely wanted to be more of a biologist when I was young, probably from watching so many nature shows on TV, and also had a microscope when I was young and would just go out in the backyard and find random stuff and, you know, spend hours just, you know, trying to look at it, investigate it, and figure something out. And also more biology when I was in high school. Had a really inspirational teacher, and just loved taking biology in high school. And one of the most memorable things that still sticks with me from that was dissecting a frog in biology. I don't know if people still do that anymore, but it was just so eye-opening, and something that I don't think you can really appreciate the same way from a video or slides, but actually cutting it open and seeing all of the organs inside. And it was really just the discovery element was just tantalizing.
So some of you have said that when you were growing up you were thinking about maybe being in different fields. Can you in your mind's eye peel back the time? What did you want to be when you were 8 years old? Do you remember what you wanted to be way back when?
Oh, I wanted to be a marine biologist. I've always been I've always been kind of a planner. So when I was basically from the ages of like 3 to about 10, I wanted to be a marine biologist, and I had like mapped out where I was going to college and all of that. I, for some reason, didn't remember that grad school was a thing, or I didn't know, but I knew I wanted to go to, knew where I wanted to go to undergrad. And then I, around middle school, switched over to wanting to be a medical professional. So, wanting to be a doctor, and had, of course, also mapped all of that out. But yeah, so I kind of had always wanted to be in a science-related field.
Yeah, I would say I was saying a little bit how I wanted to be a biologist, and I think also at that age wanted to be a doctor and an astronaut. And somehow that all eventually boiled down to chemistry, because I think chemistry is useful in all of those and so many other fields. It's like central science that can be have influence to a lot of other disciplines. So I guess that's eventually how it ended up being a chemist.
I wanted to be an astronomer, hardcore, when I was 8. I remember I had a couple of books on space, and just reread them obsessively. And there was a time when if you asked me to point out anything in the sky, I could just be like, yep, I know exactly where that is and what time of year it's going to be up there.
Yeah, I was kind of like that with dinosaurs. I really wanted to be a paleontologist, and still actually think that'd be pretty cool. But
I have paleontologist friends. I can hook you up.
Yeah, I mean, I think I had an encyclopedic knowledge of dinosaurs. I just had an enormous book and just loved reading it, and then acting them out to random people, and I'm a 5-year-old and probably seeming very a very strange child. But yeah, I love dinosaurs.
I definitely, at one point, my mom likes to tell a story of me as a 4-year-old who had memorized those Zoo Books magazines. I don't know if any of y'all got them, but I was correcting zookeepers, in public, because I had just memorized all of these facts, and it turns out I was right. But I was, yeah, I obsessively read or had them read to me and like would correct my parents if they like tried to play around with it. So.
Well, there's a reason that we're all doing this over Zoom right now. So what is something that you've been doing at home that you've been particularly enjoying? What's something that you do that's been keeping you happy and healthy while we're all self-quarantine and self-isolating?
Well, my husband and I adopted a cat, and he's here.
What's his name?
His name is Wolseley, and he is very unhappy to be held right now. But it's been great having an animal. He's been the mental health MVP of isolation.
I've mostly just been taking, like, I already exercised a lot, but I've been like exercising even more just as kind of a sanity check, and it just like I'm a very anxious person, and just kind of keeps all of that in check, so I'm not just kind of sitting in a corner and shaking a little bit, because that's what I would be doing otherwise.
Yeah, I've been doing like online bar classes because I also have some like chronic pain in my neck and shoulders, and it's amazing. Like I feel better when I do it.
Yeah, the exercise part is something I've found really hard to keep up with. I didn't really appreciate how much I would normally just walk around every day, just being in the lab and doing whatever, going from room to room, because I got a lot more steps in my normal life before now. So now my wife and I always go out on an afternoon walk around the neighborhood just to get out and get a little exercise. And we often see some of the same people in our neighborhood now also doing the same thing.
Yeah, I think I told you guys this in our little pregame chat, but like when quarantine started, I like basically didn't know how to cook, and now I've like that's been my like alternative to doing lab chemistry is just like cooking a lot, and I love it. It's been really fun, and I think like just like wondering about like all these like different flavors and like different like food bases and like why does it taste that way? Yeah, and also you get to eat delicious food, so it's been a good hobby to pick up.
Yeah, it's an interesting too, because like not having a commute means that I've got to like do different things, which is nice. One thing that I haven't had enough time to spend on is like I play several instruments, but like commuting every day and then working and then coming home and just being absolutely exhausted. Whereas now, if I want to take a mid-afternoon break, I can just grab a mandolin and go sit on the porch, which has been nice.
Yeah, I will say something that's been really nice for me is so my husband is working from home as well, and so usually when I was working in the lab, I would get up at, before 6, and I would be out the door, and I just wouldn't see him in the morning. And now we have like a little ritual where we split a pot of tea after he has a morning meeting, and it's really nice to be able to have that as well. Also books. I've been reading a lot of books.
Well, we're about to wrap it up, so this will be the final question. It's going to be a self-promotional one, I'm afraid. So you're all PacSci Science Communication Fellows. Do any of you have any memories that you'd like to share? Anything that you particularly have enjoyed participating in, or any exhibits that you enjoy at the Science Center? Does anything spring to mind? Any great experiences or interactions that you've had with the public while you've been doing Meet a Scientist?
I think for me, I've really enjoyed when I do my little demo experiment. There's a sort of a surprising twist in there, and I really enjoy when guests just like are genuinely surprised at the outcome of this little experiment with my like box of ping pong balls, simulating this sort of chemical system.
Yeah, in my exhibit, I have basically molecular models that chemists use to build molecules, to build models of molecules. And I always have some example molecules on a piece of paper that people can make, and I tell them about what the molecule is and what it's used for, and so forth. But I also give people the option to just invent their own molecule by putting atoms together in different arrangements, and that's usually what the kids do, and it's really fun to see them be creative and invent something new, and then we talk about based on what the atoms are and how they're put together and what's connected to what it talk about what it could be useful for. And so I have to try to think on my feet to try to think of what this crazy molecule could be useful for. But it kind of often does have some sort of useful application or idea that I hadn't really thought of before. And those are the kinds of things that really do lead to progress in science.
Thank you, Delwin. I know that everyone who goes to PacSci appreciates you inspiring that curiosity to explore and try things out, and that you listen to folks who are in the Science Center and can learn from that as well. Thank you. Anything else coming to mind for anyone else?
Yeah,
Oh, go ahead, Brenda.
The last time I did an in-person Meet a Scientist, had a really fantastic conversation with a small child who asked me all the questions on all the things. Like, we started out talking about dirt because that's what my activity is, but at the end I was getting questions about the gut biome and why are some bacteria good and some bad. And that was a lot of fun. I like being able to think about things that aren't just my research when I do these kinds of things.
I was gonna say something kind of along those lines. Is I always really like, whenever I go to one, I like seeing what the other fellows are doing, because it's really fun to get to talk to other people in STEM who I might not, come across because they might be working at a different institution, or even at UW because it's huge, in different departments, and to see what's going on with everyone is really cool, and to see the passion that everyone has for what they've done. It is inspiring, as trite as that is.
Well, thank you so much to all four of you, to our Science Communication Fellows who are live streaming themselves from their homes and have joined us today and shared their work and their experiences and themselves. We really appreciate all of you. Thank you to everyone who's been tuning in. This is going to be saved on PacSci's YouTube channel, so if you want to share it with any friends, family, it will be saved posthumously, so please do that. If you've not done so already, we would love it if you, to help us ensure that Curiosity Never Closes by donating to the Pacific Science Center at pacsci.org/support. We'll be doing this again next week at the same time in the same place. So we look forward to seeing everyone then too. So bye for now. Thanks.